Okay, so I want to put all of this together into a single sort of question where we combine the algebra we did for the first test with this idea of functions and graphs. So I'm going to do all of this for a particular function. So I'm going to take f of x equals 5 minus x plus 1 times x minus 3. If you hop on Desmos, which is just desmos.com, you can pop up what the graph of this function looks like. Namely, the graph of this function ends up looking like this. So we can keep that in mind as we work on this question. So I'm really going to ask 4 different questions here. I'm going to ask the questions, what are the x and y intercepts? What are the points on the graph with x-coordinate 5? And what are the points on the graph with y-coordinate 5? Now, just looking at the graph on your screen, you should see that there is one y-intercept, and that y-intercept has a positive y, and that there are 2 x-intercepts, and that one of those x-intercepts has a negative x, and one of them has a positive x. Let's do the x-intercepts first. So remember, when I look back at this function, this x here, that's the input. And this thing over here, that's the output. And x-intercepts, remember, correspond to places where the output is 0. So that is, x-intercepts are going to correspond to places where this 5 minus x plus 1 times x minus 3, where that's exactly 0. So to find the x-intercepts, I'm going to take the output, and I'm going to set it equal to 0. And now I'm going to solve this equation. And I'm going to solve it in exactly the way that we solved this kind of equation back in 1.1. So FOIL this out. X squared minus 2x minus 3. Distribute the minus. Again, be sure you're distributing this minus sign. That's really going to come up a lot as an error that causes you to get these questions wrong. But once you've done that, we get here. And I want to note there's this minus sign here at the front. And that minus sign there is going to be really annoying. But there's a nice way to get rid of it. Namely, I'm going to multiply the entire equation by minus 1. Okay, really, I'm saying I'm going to multiply both sides by minus 1, which is going to have the effect of flipping every sign. So I'm going to get x squared minus 2x minus 8 equals 0. Okay. If you ever are facing a negative x squared, you can always fix it by multiplying by minus 1 like this. And that gets us back to our most comfortable space where we just have x squared minus something equals 0. So I can factor. So I'll get x minus 4 times x plus 2 equals 0. It'll give me x is 4 or x is minus 2. Remember, when we looked at the graph of this function, we saw that we thought that there was one positive x-intercept and one negative x-intercept. Now, on the homework, most of the time it asks you to write it out as a point with x and y coordinates. But remember, we found these points by finding the places where y was 0. So the actual answer here would be best listed as 4, 0 and minus 2, 0. That is our answer. All right, so the good news is that for x-intercepts, yeah, we have to do this much work. Y-intercepts, though, are going to be very little work. And here's why. Y-intercepts correspond to the input 0. Okay, that is, they correspond to x being 0. Which means that to find the y-intercept, what I'm really doing is finding f of 0, which is 5 minus 1 times minus 3. Minus 1 times minus 3 is plus 3, so this is 5 plus 3, which is 8. Again, I want to list this as a point with both x and y coordinates, but again, the input here was 0, so my final answer here is 0, 8. And again, I want to emphasize we saw this point in the graph when we started this. So really, what we just learned is that whenever you're asked to find the y-intercept of something, that is a really fancy way to ask you to plug in 0. That's all you have to do to find the y-intercept. And so, if I want to summarize here what's going on, for x-intercepts, we're setting the thing equal to 0. And for y-intercepts, we're plugging in 0. And make super sure when you're doing this you don't flip these two. But that wasn't the only question I asked. I also asked if you took this function, f of x equals 5 minus x plus 1 times x minus 3. I also asked for all the points on the graph of this that look like 5 comma something. And I also asked for all the points on this graph that look like something comma 5. Let's look at this one first. If I want to look at all the points on the graph that look like 5 comma something, how am I going to get those? Well, here's the thing. This 5 that I know, it's in the x slot, so that means it's an input. So really this question is, what output corresponds to the input 5? Now, this is, again, a really fancy way of asking, it turns out, what's f of 5? Well, what is f of 5? F of 5 is 5 minus 5 plus 1 times 5 minus 3. Well, that is 5 minus 6 times 2. So 5 minus 12. And 5 minus 12 is minus 7. And so the point on the graph with x-coordinate 5 is 5 comma minus 7. So, in the same way that this asks what output corresponds to the input 5, this question about all of the points on the graph with a 5 in the y slot, this is really asking what inputs correspond to the output 5. Or put another way, we're really here asking f of what is 5. And so my way of solving this is going to be, again, to take the output, which is this piece, and set that equal to 5. That's really what this question is asking us to do. Okay, and I'm going to subtract the 5 over to here and add the x plus 1 times x minus 3 to both sides. So that's going to give me 0 on the left because I have 5 minus 5 is equal to x plus 1 times x minus 3. And actually, I'm very lucky here because I actually already have 0 is equal to, and then something that's factored. Again, I'll emphasize from the earlier videos, it needs to be 0 before the factorization helps you at all. But here I really did get 0 equals this factorization, and so I can more or less read off my solutions, which are minus 1 and plus 3. And so there are, in fact, 2 points with y-coordinate 5. Namely, those 2 points with y-coordinate 5 are minus 1, 5, and 3, 5. And you can readily verify that if you plug in minus 1 or plug in 3 to this equation, that you in fact get 5. Because if, for example, I plug in minus 1, I'll get 5 minus minus 1 plus 1. But that's 0, so I'll get 5 minus 0 times who cares? And that'll be 5, like I had claimed. All right, I want to do another question of this sort with a different function, just so that you have a second example to look at as you work through this in the homework. Namely, I want to look at the function g of x is 2x plus 3 divided by x minus 4. And I again want the x-intercepts, the y-intercept, and this time I want the points with x or y coordinate equal to 10. Just like before, I can go ahead and pull you up a Desmos graph of what this looks like so that you know what to expect in terms of an answer. You expect that there will be one x-intercept and one y-intercept. The x-intercept and the y-intercept will both be negative. And if I tell you that I graphed this, in fact, on the range from minus 10 to 10 for both x and y, then you can see we expect there to be 1 point with y-coordinate 10 and 1 point with x-coordinate 10 on the graph. Let's start with the y-intercept, now that we know that the y-intercept is the easiest of all of these. Okay. Namely, the y-intercept corresponds to saying what happens to the input 0. So namely, just what's g of 0. And g of 0 is 2 times 0 plus 3 divided by 0 minus 4, and that is minus 3/4. And so the y-intercept is 0, comma, minus 3/4. Now, the x-intercept corresponds to the output 0. So namely, it corresponds to when this function takes the value 0. And so to find that, we set this equal to 0. So 2x plus 3 divided by x minus 4 equals 0. And then we remember from the previous test that in order to find when a fraction is equal to 0, we look at the numerator. So namely, I look at when 2x plus 3 is equal to 0, and I solve this. And what I find is that there is one x-intercept, and that x-intercept is at negative 3/2, comma, 0. Next up, we want to know about points with x or y coordinate 10. So let's start with x coordinate 10. Okay. Again, when I ask for points whose x coordinate is 10, I'm really asking about input 10. So that is, I'm really looking for what g of 10 is. And g of 10 is 2 times 10 plus 3 divided by 10 minus 4, which is 23 divided by 6. And so that tells me that the only point on this graph with x-coordinate 10, as it happens, it is 10, comma, 23 over 6. And so last up, we want to find the points with y-coordinate 10. Again, that corresponds to output 10. And so I will take this 2x plus 3 divided by x minus 4, I will set it equal to 10. I'll go ahead and multiply this x minus 4 over to the other side. 2x plus 3. So I'm going to get that x is minus 43 divided by minus 8, but that's the same thing as 43 divided by 8. And so my only point with y-coordinate 10 is 43 over 8, comma, 10. If I pull back up this graph, we can really quick check that we believe everything. That is, that we believe that the y-intercept is at 0 minus 3/4, that we believe that the x-intercept is at minus 3/2, comma, 0, that the point 10, comma, 23 over 6 is on the graph, and also that the point 43 over 8, comma, 10 is on the graph. All of that works with this picture.